In this lesson, we'll take a first look at security. Security is a topic that cuts across web services. That is, it cuts across the REST-SOAP distinction, it cuts across the client-service distinction. So to that end, you're looking at a working file called securityoverview.txt, and we'll also be looking at some slides shortly. For an example, what I want to do is consider a conversation between Bob and Alice. These are names that are typically used in security examples. And Bob and Alice are going to exchange messages over a communications channel, for example, over an HTTPS channel. Now, security has basically two fundamental levels. The first I'm going to call the wire level. It could also be called the transport level. We'll come back to that in just a moment. And the other level is characterized in general as users' roles security. And that's a phrase that's used everywhere in the computing disciplines. So let me go back to wire level security using HTTPS as an example, and we'll get into exactly what the S means later. It does mean, of course, secure, but we'll get more specific. So at the wire level, there are three basic services that a security provider should furnish. The first is known as peer authentication. Sometimes this is described as mutual challenge, and the idea is pretty fundamental. Bob needs assurance that he's communicating with Alice. Alice needs assurance that she's communicating with Bob. So each needs to authenticate himself or herself to the other. Confidentiality is the next service. So the messages passed back and forth between Bob and Alice should be encrypted just in case there's an eavesdropper on the line. Finally, there needs to be assurance that the message sent from one side is the same message received on the other. Now, in general terms, the first of these, peer authentication, is the toughest challenge. We'll get into details in the next lesson. Confidentiality and integrity in modern systems are pretty sound. Now let me turn to users' roles security. As noted here in the first sub-bullet, this is a two-phase process, the first phase being required, the second being optional, and the first phase is called user authentication, not to be confused with peer authentication, and this is familiar to most of us. So, for example, if I go to a shopping website such as Amazon and I want to place an order, they ask for my email, that's my identity, and then they ask for a credential that vouches for that identity. And the credential, of course, is typically my password. I'll come back to that with the Amazon example in just a second. The second optional phase is known as role authorization, and the idea, again, is intuitive. If I log into Amazon, I'm allowed to place an order, but unfortunately, I am not allowed to set the prices. So Amazon does that. I don't have the security role that would allow me at Amazon to change prices. Now, let me take something that we've already seen. Let me talk about this user authentication with respect to Amazon, because we've seen three Amazon clients so far, two in REST, one in SOAP, and under the hood, they all do basically the same thing. So when I register with Amazon, I get an access ID, so that's my identity, and I also get a secret key, and the secret key is what I use to create a credential that vouches for that identity. So let me get specific. In the three clients that we've seen in the code under the hood, the client creates a 160-bit hash value using my secret key. The important point is made in two. That is, it's this hash value and not the secret key itself that travels over the wire. This hash value is known in security jargon as one-way secure. That is, even if a bad guy gets the hash value, and even if the bad guy knows the particular algorithm used to create that hash value, the bad guy is not able, well, statistically, it's improbable that the bad guy could use that information to get the secret key. Finally, Amazon on the receiving side has, of course, a copy of my secret key, and it uses that secret key on the same data to regenerate the hash value, and then it simply compares the two. If they're the same, it takes my credential as legitimate. If they're not the same, Amazon basically refuses the connection. Now let me try to summarize these points using two simple slides. The first slide has Alice and Bob again, and the idea is that Alice intends to send a message to Bob. Eve is the typical name used for the eavesdropper. So the first thing that has to happen is Alice must be assured that it's Bob rather than somebody else on the other end, and Bob needs to be assured that it's Alice rather than some imposter on the other end. So this is the peer authentication or mutual challenge phase. Once Alice and Bob are assured of the identity on the other end, they can start exchanging messages. So Alice sends a message to Bob and encrypts the message so that even should an eavesdropper such as Eve intercept the message, Eve is going to have a very, very difficult time. Basically, a computationally intractable task of deciphering that message. Finally, Alice and Bob both need to be assured that the message that Alice sends is the same message that Bob receives. And that's the integrity service that the security provider should furnish. Now let me move on to the second slide. This slide summarizes users' roles security. So let's start at the right. So suppose I'm going into a pay-for web service. The secured resource might be the entire service. It might be certain operations within that service. So for example, some aspects of the service, a list of products to buy, for example, might be publicly accessible, but ordering. So the ordering operations, for example, in an e-commerce service, those might be secured. So the idea is to get to the secured resource, I have to go through at least user authentication and perhaps role authorization as well. So to do that, on the left, I provide an identity, so for example, a username, an email, whatever, together with a credential. And the simplest credential, the most familiar one to all of us, of course, is the password. The user authentication phase then checks that credential. If I get through that, the second optional phase is role authorization. This is typically done through a database lookup or the like. In other words, the service in this case is going to check to see if I'm authorized to perform whatever operation I want to perform. For example, am I allowed to place an order? Yes. Am I allowed to change the price on the thing I'm ordering? No. This first look at web services security will now lead to a division. So what we'll do to begin is we'll focus on wire level security. And once that's in place, we'll come back and look at users' roles security.